Hello, welcome back student to design and analysis of algorithm subject. Today we are going to start the unit 2. Before going to start the unit 2, we will discuss what we covered in unit 1. So in the unit 1, um, we covered analysis of algorithms. Analysis of algorithm, like you can see here in the bracket, this many things are there. This all will come under in analysis of algorithm. What are the things? Algorithm specification, okay, and we'll see the performance analysis and space complexity, time complexity, practical complexities, performance measure. This all are the things are is on algorithm. So what is our algorithm specification? If you remember, in the algorithm specification we have 5 things. First one, we have input, at least sorry first one is input. 0 or more input can be applied to any algorithm. Second one is output. At least one output is compulsory, okay, at least one output. Third one is finite number of steps, means finiteness. Whatever the problem you are solving for with the help of algorithm, that is should be finite number of steps. And correctness, fourth one, whatever you are doing, that should be correct. Means if you are performing the operation addition, so that should be addition only. You should not do some modification middle of the algorithm. And the last one is whatever the desired output you have, that should be get with the help of this. If we have this kind of all things, input, output, finite number of step, correctness and efficiency, then only your algorithm you can write, okay. And you cannot write algorithm for if any one of the specification is not satisfying. So specification or characteristics all are same. So here, like web services, we cannot write the algorithm for the web services, okay, web services. In the same way, performance analysis, how it is performing and what is the space complexity, how much space is taking to execute the program, and time complexity, sorry, space complexity is how much storage is needed to store the program. Time complexity is how much time is taking to execute the program. Practical complexities, like in the real world you can write any kind of uh, algorithm, like if you want to make a tea, like whatever the things are there, if it is satisfying all this algorithm specification, then you can write the algorithm. Performance measure also we saw, okay. And the major important thing in the design and analysis of algorithm is asymptotic notation. This is the important notations are there. With the help of this only we can easily identify what is the time complexity of your program. So mathematical calculation can be done with the help of asymptotic notation. In the asymptotic notation, in your syllabus, the three things are there, three notations are there. First one is a big O, big omega, and big theta. These three things are there: big O, big omega, and theta. So as we have discussed in the previous videos, all videos are available for all this. Big O, okay, as we have discussed in the previous videos, big O is on upper bound, it will work on upper bound. Big omega is work on lower bound, and theta is a middle between the upper bound and lower bound, it is average. Okay, this is theta is in average, big omega is a lower bound, and big O is on upper bound. So you can go and watch the video, lecture number 4, then you will easily understand these three topics. Review of elementary data structure. So like whatever we are performing, whenever we are talking about the space complexity and the space, we must have a data structure. So we saw the heap and heap sort, and we saw some of the data structures like array, link, stack, queue. These all the things we saw in the data structure. Heap and heap sort, hashing, and we saw the set representation, union and find. This one question definitely it will come from this: find, union, and set representation. How will you represent the set? And here this is disjoint set. This will come under in disjoint set. What is disjoint set? Two sets should not be have a same element. It is called disjoint set. So in the first unit we covered this. If you did not see the video, or you did not watch the video, go and watch the video, then you can easily understand these topics in the video. So this is about the unit 1, and we completed the unit 1. Now we will go to the unit 2. In the unit 2 you have two methods, means two chapter in the second unit. First one is a divide and conquer, and the second one is a greedy method. Divide and conquer and greedy method. And today we are going to see a small introduction about the divide and conquer, and we'll see what we have in the divide and conquer, and we'll see what we have, the topics we are going to learn in the greedy method. Okay, we are going to see the topics what we are going to learn in the unit 2, divide and conquer and greedy method. Yes, now in the greedy method we have a find, maximum and minimum. Okay, we'll see how to find and minimum and maximum. And in the divide and conquer technique, this is one of the technique is there for performing the, like with the help of this we can get the data and we can solve the problem. This is one of the method to solve the problem. So what kind of problem can be solved with this method? That is find maximum and minimum problem. Whenever we have a maximum and minimum problem, then you will use the divide and conquer, then it will be easy for you. And divide and conquer has a merge sort. Okay, divide and conquer technique can be used for merge sort, and quick sort will also come under in divide and conquer, selection sort, binary search. Okay, this all the things will cover in divide and conquer. So we will see what is divide and conquer. Okay, so these are the things we are going to learn in this unit 2 first chapter, that is divide and conquer. If we go to the second one, greedy method, in the greedy method we will have knapsack problem. Okay, in the name itself you can see it is a greedy method. Whenever the greedy method is occurred, every time it need a more accurate result. Okay, so this is some of the problems we can solve with the help of greedy method, that is knapsack problem, optimal storage on tapes, job sequence with deadline, optimal merge pattern, and we'll see the minimum spanning tree, single source shortest path. These are the this kind of problems we can solve in greedy method, all these problems. Okay, as per your syllabus, these are the things are there in your syllabus. With the help of greedy method we can solve the problem. So the major important part of algorithm, there are different methods are there to solving the problem, like divide and conquer, greedy method, dynamic programming, branch and bound, and all things. So second unit is very important, and in this you are going to learn the divide and conquer is one method, and the next one is greedy method. These two methods we are going to learn in second unit. Then in the third unit, in the fourth unit, in the fifth unit if we go, then we'll see the dynamic programming, uh, branch and bound technique. Okay, that all the things we are going to learn in the coming classes. So in this unit 2, very important. Okay, and this will be very easy for you because you have already have learned this in C programming as well as C++. Okay, merge technique, sort technique, selection sort, binary search, the same thing is there, but how it is working, that we will see with the help of divide and conquer method, and we'll see the algorithm as well. So these are the things we are going to learn in today's means in unit 2. Okay, and today just we will see what is divide and conquer. Okay, we'll see the introduction of divide and conquer. So in divide and conquer approach, the problem is divided into smaller subprogram, and then each problem is solved independently. When we keep on dividing the subproblem into even smaller subproblems, we may eventually reach a stage where no more division is possible. So what is this means? If we have a problem, okay, it is dividing into subproblem. Okay, SP, subproblem, subproblem, then it will solve S and it will solve and merge result. Okay, don't worry, this diagram is already available with my today's lecture. Just for driving, draw here to show you the definition of this. What it is doing, whatever the problem, okay, is divided into a smaller sub problem, okay, 1 2, then again if more problems, then it will divide more problem. So, and each problem is solved independently. After that, independently, every problem, whatever the sub problem you are dividing, that is solve independently. When we keep on dividing the sub problem into even smaller sub problem, we may eventually reach a stage where no more division is possible. After that, if there is no more division, then only uh, it will solve and give the result. Okay, so no problem, I will show you this. Let's go here. Okay, so here, divide and conquer. Just now we saw this. Okay, the divide and conquer approach to problem is divided into smaller sub problem, and then each problem is solved independently. When we keep on dividing the sub problems into even smaller sub problems, we may eventually reach a stage where no more division is possible. Okay, the next one, the atomic, those atomic smallest possible sub problems, fractions, are solved. So whatever it is dividing sub problem, at the end we cannot divide more. At that fraction, it will solve. The solution of all problem is finally merged in order to obtain the solution of an original position. First it will divide the main problem in sub problem, then after that it will merge in order to obtain the solution of a original problem. Broadly, we can understand divide and conquer approach in 3 steps. Okay, what are the 3 steps? First one, divide. What is divide? Is break. What is conquer? Is solving. What is the third one? Is merge or combine. So this divide and conquer technique we can understand in 3 steps: divide and divide or break, conquer or solve, merge or combine. These are the 3 step procedure. This step involves breaking the problem into smaller sub problems. Okay, the problem into smaller sub problem. Whenever we have a problem, what is the work of divide? It will divide in a sub problem. Sub problem should represent a part of original problem. Okay, whatever we have a original problem, that we are dividing in a sub problem. This step generally take a recursive approach to divide the problem until no sub problem is further divisible. Okay, recursive approach is nothing but it will call by itself and it will divide the problem until no sub problem is further divisible. At this stage, sub problem become atomic in nature but still represent some part of the actual part. Okay, so this is, what is this? Atomic. At this stage, sub problems become atomic in nature but still represent some part of the actual problem. So this is divide. How the divide is working is this. Next, conquer. What is a conquer? The step receive a lot of smaller sub problem to be solved. Okay, it should be solved. Generally, at this level, the problem are considered solved on their own. So whatever the problem we it will divide, so after that it should be solved by itself. Okay, solved by itself, their own, it will solve the problem. So two things is finished. First one is big problem. Okay, big problem is divided into sub problems. Okay, then after sub problems, individually it is solved by their its own. And the last one, now merge or combine. When the smaller sub problems are solved, this stage recursively combines them until they formulate a solution of the original problem. Okay, what is first one is dividing, is recursively dividing in the sub problem until it will reach there, until it no possible of divisible. Okay, in the same way, merge is merging the sub problem recursively until we reach the formulate solution of the original problem. Okay, this algorithm, this algorithmic approach work recursively on conquer and merge steps, works so close that they appear as one. After dividing the subproblem, it is solve this that problem, and after that when it is start combining recursively, then it will reach to one. Big problem is solved in, and we will get the solution. Okay, so here, okay, these three approaches are there, three steps procedure. With the help of this, we can go with the divide and conquer approach. So I was talking about this diagram. Okay, first we have a problem, then it is divided into sub problem. Okay, then sub problem is solved and solution to the problem individually. Whatever the individually problem is there, like as here we are doing by its own the lowest problem. So here the sub problem is solving by itself and we are getting the solution. Then after that, how many solutions are there, we are combining, we are combining recursively, and we will get the solution to the problem. Okay, so this is a diagram you need to draw, or if it is asked in the exam. And for easily understanding purpose also, this is a very simple diagram. Problem is dividing, first step. Second one is solve sub problem, conquer. And the third one is combine. So these three things are there. Okay, first one is divide, second one is solve, and third one is combine. These three steps what we have done here: divide, conquer, merge. Divide, conquer is nothing but solve and combine. Okay, so this is an introduction of divide and conquer. Okay, so we will see the example of this divide and conquer here. The following computer algorithm are based on divide and conquer programming approach: merge sort, quick sort, selection sort, binary search, stress and matrix. These all are the example of divide and conquer. But here there are various way available to solve any computer problem, but the mention are the good example of divide and conquer approach. This problem, it is not compulsory you can do with this divide and conquer only, but if you do with this, then you will get the best result. But apart from this, if you want to do merge sort, quick sort, binary search, selection sort, Streisand matrix, then you will get uh, different method also is there, but it take a lot of time, it need more space, and it is not suitable for that. So the best example for the divide and conquer is merge sort, quick sort, selection sort, binary search, stress and matrix, recursively find maximum and minimum. Okay, these all are the topics which will be best suitable for the divide and conquer. Okay, so we will go to here. So today we saw some of the topics in divide and conquer. What are the topics we are going to cover in the divide and conquer, and what is divide and conquer also we saw here: greedy method and introduction to divide and conquer method. We saw these are the things. In the next class we will see one of the problem, we will take one of the problem and will solve by taking the example of divide and conquer. We will take one of the example and we'll solve. Okay, thank you very much. We'll see you in the next class.